For more than 70 years, scientists have wrestled with a question that refuses to disappear. If the universe is so vast, so old, and filled with countless planets, where is everyone else? This puzzle, known as the Fermi Paradox, began in 1950 when physicist Enrico Fermi casually asked, "Where is everybody?" during a discussion about flying saucers and extraterrestrial life. The question sounded simple, yet it exposed a contradiction that still troubles researchers today. On one hand, the universe appears to provide endless opportunities for life to emerge. On the other, humanity has found no confirmed evidence of intelligent civilizations beyond Earth. The numbers behind the paradox are difficult to ignore. The universe is roughly 13.8 billion years old, while Earth formed only about 4.6 billion years ago. That means billions of years passed before our planet even existed. During that immense span of time, other stars and planets had opportunities to form, evolve, and perhaps host life. Our galaxy alone contains hundreds of billions of stars. Observations from missions such as Gaia have revealed an astonishingly complex Milky Way, while astronomers have confirmed thousands of planets orbiting distant stars. Many of those worlds exist within regions where temperatures could allow liquid water, one of the essential ingredients for life as we know it. Researchers estimate that the Milky Way may contain hundreds of millions of potentially habitable planets. Even if only a tiny fraction develop life, and only a fraction of those eventually produce intelligent beings, the galaxy should still contain numerous advanced civilizations. Yet the silence remains. No verified alien signal has ever been confirmed. No unmistakable message has arrived from another world. No spacecraft from an advanced civilization has appeared. The contradiction between expectation and observation remains unresolved. One possibility is that life itself is extremely rare. Another is that intelligent life rarely develops. A darker possibility is that civilizations tend to destroy themselves before they become capable of spreading across the stars. Some researchers suggest that advanced societies may only broadcast detectable signals for a brief period before adopting technologies that make them nearly invisible. Others argue that humanity has barely begun searching and therefore should not be surprised by the lack of results. The search for extraterrestrial intelligence formally began in 1960 when astronomer Frank Drake pointed a radio telescope toward two nearby stars. He hoped to detect an artificial signal that could indicate the presence of another technological civilization. Nothing definitive was found, but the experiment launched a new scientific field. Drake later introduced his famous equation, which attempted to estimate how many communicative civilizations might exist in our galaxy. The equation highlighted a crucial uncertainty. How long does a civilization remain detectable? That question matters because space is unimaginably large. Even the most ambitious searches examine only a tiny fraction of the sky. Programs such as Breakthrough Listen have surveyed vast regions of space and millions of stars, yet compared with the scale of the Milky Way, these efforts represent only a small beginning. A signal might arrive from a direction we are not observing. It might be too weak, too brief, or transmitted using methods we do not recognize. We may simply be listening at the wrong time. Occasionally, mysterious signals generate excitement. In 1977, astronomers detected the famous WOW signal, a strong burst of radio energy that appeared unusual enough to attract worldwide attention. However, it never repeated, and its source remains unknown. Decades later, another intriguing signal detected near Proxima Centauri briefly raised hopes, only to be traced back to human-generated interference. Such incidents demonstrate how difficult the search truly is. Earth itself produces countless signals capable of confusing sensitive instruments. Because of these challenges, scientists have expanded their search beyond traditional radio messages. Instead of waiting for a greeting from another civilization, researchers now look for technosignatures, indirect evidence of technology. A technosignature could be a radio transmission, a laser pulse, unusual atmospheric chemistry, excess heat, or even massive structures affecting a star's light. The goal is not necessarily to hear aliens speak, but to detect evidence that advanced technology exists somewhere in the cosmos. Modern instruments have transformed this effort. The James Webb Space Telescope can analyze the atmospheres of distant planets by studying starlight passing through them. Webb has already detected important molecules such as carbon dioxide and methane in the atmospheres of exoplanets. These discoveries do not prove life, but they demonstrate that scientists can now investigate distant worlds in ways that were impossible only a generation ago. Humanity is no longer simply counting planets, it is beginning to examine their environments in detail. Another possibility is that advanced civilizations deliberately avoid contact. This idea is sometimes called the zoo hypothesis. According to this concept, older civilizations may observe younger worlds while avoiding interference, allowing natural development to continue uninterrupted. Earth could effectively be part of a cosmic nature preserve. Although intriguing, the theory requires many independent civilizations to follow the same rule, making it difficult to verify. A more troubling explanation is known as the Great Filter. This hypothesis suggests that somewhere between the emergence of life and the development of a long-lasting spacefaring civilization lies an obstacle that few societies survive. The filter could occur at any stage. Perhaps life rarely begins. Perhaps intelligence rarely emerges. Or perhaps technological civilizations eventually create dangers they cannot control. If the Great Filter lies ahead of humanity rather than behind it, then our future may be far more uncertain than we would like to believe. This concern becomes especially relevant when considering modern technology. Humanity now possesses nuclear weapons capable of devastating civilization. We have altered the planet's climate and ecosystems on a global scale. At the same time, artificial intelligence is advancing rapidly. Unlike previous inventions, AI has the potential to assist in designing new technologies, solving complex problems, and accelerating scientific progress. Some researchers worry that increasingly capable systems could develop faster than society's ability to manage them responsibly. Warnings about advanced AI have come from respected scientists and technology leaders. Concerns range from economic disruption to the possibility of losing control over systems that become significantly more capable than humans in certain domains. Whether these fears prove justified or not, they highlight an important point. Intelligence creates power, and power introduces risk. A civilization may reach a stage where its own creations become its greatest challenge. This leads to one of the most unsettling interpretations of the Fermi Paradox. Perhaps many civilizations achieve remarkable technological success, only to encounter a critical point they cannot survive. In that case, the silence of the universe would not reflect the absence of intelligence but the fragility of intelligent life. Civilizations may rise, innovate, and disappear before they spread across the stars. An even stranger possibility is that advanced civilizations eventually cease to be biological. Humanity already relies heavily on machines for communication, transportation, research, and decision-making. Over vast stretches of time, the distinction between a species and its technology could blur completely. An ancient civilization might transfer its intelligence into digital forms, operate through machines, or exist in ways humans would struggle to recognize as life. Such beings might not live on planets, send radio greetings, or behave in any manner we expect. If that is true, our search may be based on assumptions that no longer apply. We continue looking for civilizations that resemble us, but the oldest intelligences in the galaxy may have evolved beyond anything familiar. The Great Silence may not mean nobody is out there. It may simply mean that the universe is filled with forms of intelligence that are difficult for a young technological species like humanity to detect, understand, or even imagine.